Hi everyone, Miss Andronicus here, and today we are using the position to term rule and calculating the nth term. Okay, so the position to term rule for a sequence is another way to find patterns. The position refers to where the term comes within the sequence and the rule that then connects the position with the term. The position can be referred to as n and used in the rule as the nth term and can be written algebraically as the nth term equals 2n plus 5. This is a far more common way to work with sequences because it allows us to not just go from term to term, from one to the next to the next. It allows us to make big jumps to mathematically then be able to calculate them. So I just want to have a look at this example. The nth term equals 2n plus 5. Write down the first 4 terms of the linear sequence. So the first term, you then need to take this formula, and if it's the first term, you replace the n with 1. So you really do need to use substitution here. Substitution. So if it's the first term, you put the 1 in that spot where n was, okay? And then you work it out. So the first term would be 7. Second term would be 9, third and fourth there, okay? You can use the linear sequence to fill in a table, and a table really helps you to be able to organize your thoughts with this. So if you put the 1 there in the first one, you can substitute it into the formula. So it'd be 2 times 1 is 2 plus 5 is 7, and then the answer goes immediately underneath. The same thing for the 2 and the 9. So if it's a 2 going in that nth spot and it equals 9, it goes into those 2 boxes like that. And you look at it vertically, okay? So if 1 is substituted into the formula, that's the input, then 7 is going to be the answer, the output, okay? And as a result, you can then start to jump further into your sequence. So you don't have to necessarily go term to term now. It works instead vertically. So you look vertically at this. So if you have a look, you know what your nth term is. So any number in this position, you substitute it in. So for this answer here, it would be 2 times 5 plus 5. So 10, 15, okay? And it should match. If it's a linear sequence, you will still have a term to term there. Now, as you can see, we jumped to the 100th position. So I'm not going to expect you to find the 6th, the 7th, the 8th, the blah, 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 all the way to 100. That would just take forever. So of course, then that's where your substitution really comes in handy. And this nth term concept is really important. So you end up putting that in to get this answer. It'd be 2 times 100 plus 5. So that's going to be 205. Okay, so in really using this nth term formula, it really enables you to be able to calculate any number in the sequence. So have a look at the last one. You've been given the answer, but you haven't been given its position. So now you need to work backwards. So if we use, once again, this formula, okay, we've got 505 equaling 2n plus 5. Okay, we don't know what n is now because that's the bit that's blank. So just like you would with any algebraic equation, you would need to work that one out. Okay, so subtract 5 on both sides. That's 2n. Divide by 2 on both sides. So n would be 250. And that's how you work either your way through the expression, which is using substitution, or calculating the equation if you've been given the answer. Okay, finding the nth terms of an arithmetic sequence. When working with number sequences, you do often have to find the nth term or the rule from the sequence, and having a method to do that is more effective than just writing the whole pattern out. So the position to term rule is the most effective here. So here you've been given the example, find the nth term of the following sequence and then calculate the 47th term. All right, so first of all, we need to have a method of finding the nth term in the following sequence. Where to start? Now, yes, I know a lot of students have done trial and error before, but it does get you there eventually, but it takes a lot of time that we don't need to spend if we can just go through one step at a time. So you actually do need to consider the term-to-term rule, because there is a relationship there. Okay, so knowing how to get the term-to-term really helps. So first of all, I'm going to look at that and see if there's a pattern. In this case, it is +5, +5, +5. Okay, so that's really, really helpful to know. Now, as you saw above, the nth term comes into this format. It's something something n plus or minus something something. Okay, so if you have that format in your mind, then all you need to do is figure out what these something somethings are. Now, this term-to-term rule, once you've figured that out, here's a little hint for you. Use that term-to-term rule and put it straight in front of the n. That's the secret. So in this case, it would be +5 or just 5n, and then you need to work out the rest using substitution. Let me show you how. So I've added an extra row in this table. So what you're going to do is you're going to take at least the position, which is n, and you're going to multiply it by 5 because that term-to-term rule's there. Okay, so you do 1 times 5 is 5, times 5, times 5, times 5. Okay, so that's the first little step in the working out process. Then, to get the rest of this, you need to have a look at the difference. Okay, so if we go from 5, we've got to get all the way to -8. And it's either adding something or subtracting something. In this case, it must be subtraction, so I'll get rid of that, subtract, and it must be 13. Okay, so that's how you work through that rule. So actually, the nth term in this sequence is 5n subtract 13. Okay, and you can check that going through here. So that's 5n, subtract 13 is -3. Is 2 and is 7. Okay, so step by step, that's what you need to follow. Okay, so on the right there, I've just added in some rules for you to make sure that you have them down. Work out the term-to-term rule and put it in front of n. So set it up in your book to have, okay, nth term equals a space in front of the n, plus or minus, you've got to choose which one, and the rest. So the term-to-term rule goes here, and then substitute it in like we did here in order to figure out, well, what is the difference between that to be able to figure out the rest of that. And last but not least, the question did ask, calculate the 47th term. Once you have the rule, 5n take 13, then 5 times 47 take 13 is going to give you the 47th term, which in this example is 222. So 47th term is 222. Okay, another example, find the nth term of the following sequence and calculate the 47th term once again. Okay, so when you only get given a sequence in the question, use a table. I really strongly recommend that you use a table. So the position, that's 1, 2, 3, 4, okay, and we'll put 47th there. because we know we have to find that in the question. The sequence is 17, 14, 11, 8, and we don't know the last one. All right, so remember what we said. The first thing is to get the term to term and have a look at that pattern. So that's -3, -3, -3. Okay, so we know the nth term equals -3n, because whatever that is, we put it straight in front of that. And then we've got to work out the rest. So let's start with doing that calculation first of all. I'm going to put it underneath here. So -3 multiplied by 1 is -3. -3 multiplied by 2, etc., etc. Okay, so once I've done that, I have a look and go, okay, well, how does -3 add something to get to 17? So I know that's +20, and that will equal 17. +20, +20, +20, okay? So my nth term, and my rule in this case is this. The nth term equals -3n plus 20. The 47th term, if I continue to follow that, that's 141. And then the +20, if I keep going, is 161, okay? So that first jump is the multiplied by 3 and then +20. So I apply that rule and work it out. Okay, give it a go, guys. Good luck.